Hello, everybody. This is the first of the autumn semester 2007 public seminars sponsored by the Earth Institute's Center for the Study of Science and Religion. I hope all of you have found your way here through our website, and therefore all of you are on our email list. But if some of you are not, please make sure to sign outside so you can find out from us in time what follows from today. A series of other seminars, plus a symposium in the spring on neurosciences and free will, plus a monthly town meeting at Riverside Church jointly with Riverside Church, plus many other things we haven't figured out yet. Now, tonight's speaker is Peter Eisenberger, speaking on a topic which he chose the title for, designed to catch your interest. It does. It's called Designing Earthlings. The secondary title, Unifying Reason and Values to Address the Challenges We Face, sounds like it could be the motto of the Center for the Study of Science and Religion, and maybe one day it will be. We are probably rare, possibly unique in the country because we are a group of academics and religious people, some of us both in one person, some of us not both in one person, given to a shared attempt to understand the world through science in order to fix the world and make it better, to ameliorate suffering and diminish the risk of great disaster. One would think you don't need a center to do that. One would think good people would do that as a matter of course, but you know, we don't. So the topic of science and religion can be converted to the topic of why not. And Peter is a very good person to speak on that. Peter is a graduate of Princeton, and he has a Harvard PhD. He has been a physicist. He has been at Bell Laboratories, and he and I have, in that sense, had very similar early backgrounds. He was, for a while, the director of the Earth Institute at Columbia, and he is now engaged for a considerable time on the enterprise of, for want of a better phrase, using his intelligence to make the world better. And I don't want to spend a lot of time when you could hear Peter instead, so here's Peter Eisenberger. Thank you. Don't drop your glasses. Did you? Okay. We will have a pause while we pick up the glasses.
I don't need them. If you can find, there's one lens. Okay. Well, anyway, thank you, Bob, and thank you all for coming. As Bob said, I want to also thank him for the critical feedback he's given me during the course of this work, which has had a real profound impact on my thinking, and I want to thank the members of his staff and the Center for their input and assistance. Before I begin, I need to have a disclaimer. Namely, when I gave Bob $50,000 about 7 years ago to begin the center, I did not know it so I could speak today. But I did it because even then I understood the importance of both science and our beliefs, including those that come from religion, about guiding our efforts and our species' efforts in the future challenge we face, which I call, how do we co-evolve successfully with the planet? It's going to be very difficult for me to summarize for you 6 years of effort within this lecture. I'm going to be forced to make several simplifications and generalizations, and if I was giving this in an more academic setting, I would have to apologize profusely for that. However, I'm open to bring and discuss more of the details, and of course, anybody who is really interested can read my book when it gets published. I hope to demonstrate that in spite of the fact that I can't go through all the details with you, that my conclusions are very robust to those details. And I'll give you an example. For example, I'll use the common term, the reptilian brain, to describe that part of our brain that we inherited as a result of mergers from what was developed in reptiles over 200 million years ago. We now know that our brain was put together by the merger of 3 parts. However, if you talk to neuroscientists today, they've developed a much more nuanced explanation about the nature of those mergers and how they in fact interact. But from our point of view, those details are not that critical. What's important is that the whole structure evolved in a completely different reality, the survival of the fittest type reality than the reality we find today. And it raises the question, how well has that evolutionarily designed brain, how well is it prepared to make the decisions we have to make today? And that's going to be a very important subject for us to discuss. So for me, and many people in my generation, there was a very profound moment that changed our thought about our relationship to our planet. That is our reference frame, when we saw a picture of our planet from the moon. Right away when I saw that, it immediately occurred to me how absurd it was that we are fighting each other as our planet goes through dark, empty space. And right then and there, it was clear that we're all on the same planet, we all share it, and I've used the word Earthlings to describe that. And to use a simple proverb, united we stand, divided we fall. Today, our planet looks very different when we look at it from space, even in this short period of time. The polar caps are less white than they were before, and we see many more lights at night. And that's as clear a picture I can of the challenge we face in our co-evolutionary future between our species and the planet. Being trained as a physicist, I tried to think about this problem in sort of what I'll call mechanistic and causal terms. But right away, I had to realize that this problem is a problem about not subjected to reductionism, but is about a complex system. Now, I don't have time to go into what a complex system is, but it's been made popularized by the notion of the butterfly effect by Lorentz. That is the notion that through complicated feedbacks, a butterfly waving its wings in one part of the world can cause a change someplace else. But the basic thing you have to know about complex systems is that their future is inherently unpredictable. And we'll talk more about that in a second. However, the second thing that I realized is in this case, the causal force, to the extent that we're altering the planet, is the way our brain decides to use knowledge. And therefore, we are de facto designing Earthlings. That is, the decisions we make using our knowledge to determine the actions we are going to do is going to be a profound evolutionary force on the future of our planet. I will argue that we know enough already from the knowledge we've acquired, especially in the last 50 years, to know what changes we need to make in the way we approach this challenge, how we relate to each other, and how we make decisions. The answer that I'll propose to you is different than the ones you've heard from others. It's different than the environmentalists who think that we are the major problem on this planet. And therefore, in this ideal, we should leave nature alone. Or it's certainly different than the capitalists who believe that we are have a very successful recipe, and therefore we do not need to change. My answer is going to be that, in fact, we are not the villains in this drama. We can be the heroes of coevolution, but we need to change. As a physicist, I approached this issue from almost a completely secular perspective. And over time, however, the evidence was compelling that the most important lever on determining whether we use our knowledge well or use our knowledge poorly to address this coevolutionary challenge was the values we had in terms of our relationship to each other. And that, from that perspective, the most important value of all is the golden rule. What has also had a very profound impact on me was the recent insight I got that, in fact, if we become designing Earthlings, using our knowledge wisely to become good stewards of this planet, we will, in fact, all feel more fulfilled and happy than we do today. We'll see if I can convince you of that. Let's now begin. We have a lot of ground to cover. And because of that, I've put a lot more information on the slides than I'll be able to go through. There's some of the background information that leads me to my conclusion. If you follow the bold type in the slides, you'll be able to get the main message. And another reason I put more information on the slides is information we have now about how we learn. That is, some of us are visual learners, and some of us are auditory learners. And so by doing this, you can appeal to both kinds of learners. And in fact, the challenge we face as we look to the future is how do we interface with our knowledge in a way that we all can digest it and make good decisions about what to do in the future. So, so this is the outline of the talk. I'm going to begin by talking about what is the essence of the coevolutionary challenge, what is our role in it, then go to basic concepts that we need to understand and develop the thoughts, and then show how the knowledge of about our brain and the knowledge about how we have evolved in the past leads to certain conclusions that defines what I call the designing Earthling approach. And then I'll apply that approach in detail to the problem of global warming. So let's begin. Let's look back and go back before we could alter the planet. So this is when our species emerged about 7 million years ago in the Hominidae family, and eventually as Homo sapiens 200,000 years ago. In all that evolutionary time, we were in a situation where basically we were like other mammals, basically impacted by what the Earth system did, whether it's geosphere, atmosphere, and ecosphere did, what the evolutionary system did. It impacted us, and we had no ability to impact and alter it. But since the last ice age, what we have seen is a rapid change in the tools we use and in the social structures we bring to this problem. But basically, from an evolutionary perspective, we are totally have evolved in what I'll call the survival of fittest reality. That is, a reality dominated by local and imminent threats to our well-being. Let's go further back in time and call geological time, and think about what it was like before our life, before our species existed. If you start at the bottom of the graph, you'll see the creation of our Earth. It is symbolic of the way creation works in generally. It's by destruction, because our whole solar system was formed by the explosion of a previous star, a violent beginning. 1 billion years later, roughly, first life appeared, and for the next 2 billion years, the only life on this planet was microbes. And they are the architects of everything that you see in complex life today. They developed the reproductive machinery, and they developed the way we use energy, and so they are the designers. And in fact, a very crucial point that you'll see played out later on is if you look back at about 500 million years ago, at the Cambrian era, that began what is known as the Cambrian explosion, where instead of microbes, we now had very complex life forms that we all associate today with modern life. And I'm going to, the result, one explanation for that explosion is the fact that evolution works by mergers. There's things like hot genes that you can take whole units and combine them like an erector set into different components. And so once microbes did the work of engineering the basic components, we were prepared under favorable conditions to have an explosion in the evolution of life. So the question now becomes, what in this period of time, before we emerged, what did life experience in terms of threats? So the first thing we have to remember again is that life continually emerged through creation by destruction. That is, destruction created eco-niches that allowed new species to come in. And you can sort of get this feeling that there's been this change because there used to be microbes and now there's all this complex set of species here today. But through it all, there were a series of extinctions that caused major destruction. There's caused climate change, where there was in a period of time where we had a snowball Earth, which caused massive extinctions of life that existed beforehand. And of course, we're all very familiar with glaciation, but it's hard for us to imagine in our brains, sitting here in this local reality, that at one time there was ice covering 2 to 3 times the height of the Empire State Building, and that Long Island itself was formed. And all these phenomena of glaciation are going to happen again in the future. We're also now aware about asteroid impacts because of the well-publicized extinction of the dinosaurs. But there have been many other asteroids, as you can get if you look at the moon through a telescope and see all the pock marks on it, because they're visible because there's no erosion. And so we know there are going to be many more asteroids in the future that can cause destruction. Something you may be less familiar with are supervolcanoes. We've heard about Mount St. Helens in our lifetime, but what's sort of awesome to comprehend is that Mount St. Helens spewed 1 cubic kilometer of material into the atmosphere. And these so-called supervolcanoes, of which Yellowstone is one, will do 1,000 times as much into the air. So much so that New York will be covered about 6 inches of soot. And the whole Midwest will be blown up when, and it will, the Yellowstone goes off again. And there are even larger ones that caused a major Permian extinction where a whole region explodes and puts even 1 million times more into the atmosphere. And then, of course, we know that you can have extinctions caused by changes in the ecosystems. And the most favorite example I have of this is cyanobacteria. They're the architects of our prevalent photosynthesis process for converting the sunlight's energy into work. In the course of doing that, they emitted a lot of oxygen and changed and altered the atmosphere of our planet, causing massive destructions. So the lesson is clear. Life evolved in a way that over 99.9% of all the species that ever existed are now extinct, and that massive extinctions are a part of our future if we do not intervene. They will occur. They're a part of the natural process. Our own species has experienced this in a minor way, but with a very significant impact, because we were also, 75,000 years ago, a victim of a supervolcano at Lake Toba. And it's been speculated that that reduced the number of our population down to as many as 1 to 10,000 beings. And Professor Ambrose, who has studied this region and this period of time, has speculated that because there's a lot of shared tools, of arrows and other things that's come from different cultures, that threat propelled us to cooperate more than we had previously as hunter-gatherers. And also, he speculates that that need to communicate was the basis for the evolutionary pressure to develop language. Of course, that raises the question, which is really at the basis of this talk. Can we use our knowledge so we can change our way we conduct ourselves before the next catastrophe, or do we have to be hit like in the case of Professor Ambrose before we change? Now, the outlook doesn't look too good today, because, for example, if you look at New Orleans, we knew there was going to be a hurricane that hit it. We knew the levees would break, but in fact, if you look into the details, it's a little known fact that the money that was allocated for defense against the levees was actually spent on building bridges to the casinos on the waterfront. So that's the way we currently make decisions about threats that we know are going to occur, but they're in the distance, and we sort of convince ourselves that they're not going to be significant. However, with the Industrial Revolution, our whole species changed. It initiated an enormous change in the amount of our ability to do work through the use of energy. It resulted in us changing our atmosphere that we're talking about today. It resulted in us using natural resources and meeting our basic needs that are altering the planet as we speak. However, it's quite clear if we take a biological lens and look at our species and ask what we've done in the last 200,000 years, it's quite amazing. By any biological standard, we're an amazing success story. Our numbers have increased greatly, our lifespan has increased by a factor 3. But we are having a global impact. Now, unlike the cyanobacteria, who in their development of an energy process altered the environment, we are now, in our success, altering our environment, but we're worried about it. We're concerned about it. We're thinking about it. We're trying to put effort to solve it. And that's the fundamental difference, what we bring to the problem and what was available to life beforehand. And the question is, how do we take this concern about it and turn it into something useful? Now, as important, as significant as our impact is today, when we start to address poverty, which we should, and when countries like India and China come online in this next century, it's going to turn out that the amount of activity that humans are going to do on this planet is going to increase by 5 to 10 times. Now, I don't have time today to convince you that our knowledge is powerful enough and our energy sources are profuse enough that we can, in fact, have the whole planet of future 9 to 10 billion people living at our standards without running out of resources to do it. However, that doesn't mean that it won't have other impacts, because as you all know, knowledge is really a double-edged sword. So, how is our use of our knowledge to meet our basic needs having an impact? Well, we know it's changing the atmosphere. That can cause climate change. We know that we're destroying ecosystems that can cause ecosystem collapse. And we know we can introduce new diseases. However, when you look at these human threats and now put them through the lens of the nature-driven big threats we just talked about, we come to the conclusion of two things. Our impact on the planet is similar to what other natural life forms have done, but it's less destructive. We don't have anything that we're talking about that compares to a supervolcano, or anything we're talking about that compares to an asteroid hitting the planet. But yet, therefore it suggests that the real challenge is not addressing the local and imminent threats, but these larger and distant global threats that can impact all of life. And of course, we are, as I indicated in the case of cyanobacteria, uniquely positioned to do that because we have this ability to think and plan for the future, even though we haven't been impacted by one of these things in our lifetimes. So now we're in a different state with all this. We're now in a situation that I call coevolution. And that means if you look, that you now see an arrow going back and forth between us, our human activities, and the rest of the Earth. That is to signify that now we are also able to alter it, as well as the planet and the Earth being able to alter us. And the question becomes, how do we use our knowledge, our brain, and our human institutions to make the right decisions about how to proceed. And I'm going to suggest to you that a good paradigm to think about that is in what I call the I-we threat paradigm. That is, we are individuals, we have some view about what we're confronting in our reality, we get together in social groups and decide how to act, and those things are largely motivated in the past and still today. How do we avoid the threats or the dangers to our existence? And the basic question is, how do we use our knowledge and beliefs to be successful in addressing the threats? What I want to make clear to you is, and it's going to be seen throughout this talk, is that the critical role is played by our brain. Right? It is the device by which we see all this, imagine it all, have consciousness even of it, and so therefore how it functions is the most critical aspect of determining whether or not we'll be successful in the future. Just to put a little more detail on this I-we threat system, the things that affect us are our genes, our knowledge, our beliefs, our experience, and how all that gets mixed up in our brains. What affects our we's are our social organizations and our values, and the threats that we've always tried to deal with throughout our history deal with our basic needs, predators, conflicts, and so forth. Now, I've made a very important distinction, at least from my perspective, between two kinds of values that we have. One is the value that comes historically from our experience, from our human condition, that was known and talked about long before we had any of this knowledge about the reality in which we actually live. And the other kind of knowledge is a knowledge that's informed by the pragmatic evaluation of the current threats to ourselves and what's the best way to respond. And an important conclusion from my perspective is it turns out that those two values come up with the same answer. But we'll see that as we proceed. Well, how does this I-we threat process work in a brain-centered way? Well, we're sitting here in this room, and you each are coming with your own reference frame and thinking about the problem, right? And there's two ways that you will react to the question about global warming. One is the normal way. You take all the knowledge and beliefs you have now, and you sort of, in almost an automatic pilot, you have an answer. That's the way we decide to do things, based on our current existing knowledge and beliefs. But importantly, we also are capable of having a second process. That is, we can learn. We can change and innovate and develop new defenses against threats, develop a whole new way of thinking about the problem, and develop new organizations to deal with it. So the important thing is that learning and innovating, which is a unique human capacity, is the thing that allows us to change this framework. And when we change it, we're going to change dramatically the role of our species in their role in coevolution. Now, as I said in the beginning, I'm going to make the assertion that this coevolutionary challenge that we can now describe in the language we just developed, that is, the question becomes, how do we change this I-we threat framework in order to find the best chance to prevent the destruction and extinction to our species and other life from the global threats we both face? We have a common enemy. And I assert that we already have enough knowledge to know what the answer is and how to best use our powerful knowledge to ensure that the future of life on this planet, for all life, is better than it has been in the past. And as I said in the introduction, it's going to be an answer that's different than the two that you hear currently debated. So the designing Earthling approach, which I'll begin to develop, is that we are not the villains, we can be the stewards, but we need to change. And as I said, the subtext I'm going to bring all along is that this more global problem also has profound implication for us each as individuals and how we think about ourselves and how we think about what our existential reality is. In some sense, what I'm talking about is global mental health. In some sense, we are a dysfunctional species right now because we're living in a knowledge era with a brain that was designed for a different period of time. So now we're going to make the transition to the next segment of this talk. We're going to try to develop some language that we can use to describe and interpret the knowledge that I'm going to describe in terms of our brain and in terms of our social organizations. So the first concept is what I call the knowledge gap threat. And that's the flip side of all this positive power it gives us. And it's a threat because it's evolving, we're developing knowledge so quickly that we can't evolutionarily adapt to it, nor can we develop our social institutions to cope with it. And the best example of that, of course, is nuclear energy. It's the poster child for that. Nuclear energy is today a plausible solution to solving the global warming problem, at the same time that it's a massive threat to us using it to kill each other. Right, so the question is, why is knowledge increasing so quickly? And I would like to make an analogy with the Cambrian explosion. What's happened is that through our science, we've developed many pieces of knowledge, many important components. We're now in the stage of putting them together in different ways, like I'm doing in this talk, and creating new insights. So knowledge has a combinatorial aspect to it, that the more knowledge you have, the faster you create new knowledge. And that is demonstrated by these two factoids that I find, in some sense, hard to believe, but it seems to be true. Currently, the doubling time for knowledge is about 2 years. It was 3 years in 2000. By the time we get to 2020, it is speculated that the doubling time, that is, will create as much knowledge in 70 days than in all the history of our planet, of human activity. So the question therefore becomes, can we arrange our I-we threat framework so we use this enormously powerful knowledge, whose capacity we don't completely comprehend, but can be much bigger than it is today? And can we use it wisely? And I'm going to answer, the answer is no, if we continue to operate with the same view of our role and our relationships to each other, what I call the survival of the fittest framework. But it can be yes, if we change to the designing Earthling framework. Now, since I'm extolling how powerful knowledge is, it's very important to be clear that you can't know everything. There are limits to knowledge. And because we can't know everything, for reasons that I'll explain in a second, we have to have beliefs and we have to have speculation. And actually, what I've realized is that most of science is really about speculation. That's what drives the scientific process. Scientists have a speculation and they try to prove it. But as I'm going to indicate to you, there are many things about our planet and our life that are not provable. And therefore, in some sense, both scientists and who have beliefs are doing speculations that cannot be proven. And so that ambiguity, when you get into the fact that when you can't know everything, and yet you have to deal with things you can't know everything about, creates an interesting relationship between the speculations created by knowledge and the creation by culture. So what are the reasons why we can't know everything? Well, the most fundamental of all was done by Gödel, who proved mathematically that it's impossible to have a rational system with rules that you can answer all questions. And this has to do with what he calls self-referential questions, like I am lying. Well, if I'm lying, then I'm telling the truth. But if I'm telling the truth, then I'm lying. And so there's no way to logically determine whether I'm lying. Anything that has no outside force or is self-referential, you get in these loops and you can't determine the truth. Now, because of that, I've developed the concept of what I call the human uncertainty principle. And that, in short, means that we don't know really what reality is, as the Matrix movie shows. We only have a model of it, a reference frame of it, but we have no independent way of determining whether it's true or not, because, in fact, even the knowledge we generate and the knowledge we interpret is all done through the same instrument, the brain. We have no independent check of it. And so there's a limit to what we can say we can know. So that's very important, number one. But secondly, it's what I mentioned about a complex system. A complex system with all these feedbacks and all these things that can change means that we can't predict the future of it, how it evolves. However, we're fortunate, like in the butterfly effect, that we can say in given circumstances, there are regular patterns, like right now in a regular pattern. When we had a snowball Earth, it was a different pattern. When we had glaciation, it was a different pattern. And what happens is the unpredictability is we don't know when we're going to shift from one pattern to the other. But what we do know is if we measure the planet, we can get an early warning that the current pattern of forces and reactions are beginning to change. And so that's the way we can try to deal with complex systems. We can't be predictive of them, but we can know what various regular patterns have existed in the past, and we can measure and try to prepare for them. So if you come down here in the bottom of that view, of the view graph on the screen, you'll see the conclusions that come from here, and I want to focus on the fact of how do we defend against that? How do we defend against threats that emerge in this complex system? Well, there are two ways. One is the model of the 100-year dam, right? You build a dam, it sits there for most of the time, and when you have a 100-year flood, it protects you, right? So that's one way. Even though I don't know when I'm going to shift, I know sometimes there's going to be a 100-year flood, and I'm ready for it. The second and more sophisticated thing is something that's being done here at Columbia, and that's trying to understand by having sensors and buoys along the Pacific, equatorial Pacific, to see the change in the water temperature in the Pacific as a presage that we're entering an El Nino or La Nina phase. And when we get those change in temperatures, we can change the way we plant our crops, begin to prepare for floods and fires that are going to come 6 months in advance. And that knowledge is already being useful to us in defending against those threats. But the most important thing of all that I'm going to be carrying throughout this talk is that our decisions of how we relate to all this is really constrained by the reference frame we bring to it. So now really what I'm talking about is what I call a practical epistemology. I don't want to go into all the detailed philosophy of debating about knowledge for a long period of time, and I have a very simple approach. The simple distinction is knowledge is provable or testable, and belief is not. There are different kinds of knowledge, right? But our goal is here, how do we make the best decision? Well, what does it mean to say the best decision? And here we run into Gödel and complexity, right? So we have to have, like in mathematics, we have to have some axioms. And I'm making 2 axioms that I can't prove, but everything else after this is going to follow. So my 2 axioms are, number 1, we want to try to co-evolve successfully, right? I can't prove that's our goal. Maybe it's better that we get extinguished and some other species come along. But I'm going to be anthropogenic, and I'm going to say our role here is to try to survive and try to do as good as we can. And the second thing is I can't prove to you that, even though it seems plausible, that knowledge is the best tool we should use. There may be other ways we can approach this thing. But what I can do, if it's plausible to you that our knowledge appears like a powerful asset in our fight to defend against the threats we face, then everything else follows. And I'm going to try to make that convincing to you. But most important thing of all, what follows is how do we use that knowledge to make clear decisions? And of course we have to be able to evaluate the knowledge, we have to be exposed to it, we have to understand its limits, and we have to be able to understand when we can design a solution to it or when we have to just be adaptive. And most important of all, we have to be open to the fact that we can change our reference frame. So in my view, we're entering an era, a very exciting era actually, that parallels the Industrial Revolution. In the Industrial Revolution, we used tools to change the way we physically manipulated the world. I claim in this knowledge revolution we're in, or knowledge age we're in, we're going to now use tools to enhance our ability to manipulate the knowledge we have to make good decisions. And that's the exciting challenge we face, right? That change in our mental capabilities to use knowledge by using tools. If we apply this basic concepts quickly to global warming, I don't have time to go into the nuanced arguments about global warming, but I want to make some simple points. First of all, the point is, yes, we can know the planet is warming. We can measure that empirically. That's solid knowledge. We take the temperature deep in the planet, we take the temperature up in the atmosphere, and they all tell us the planet is warming. However, the questions, are humans causing global warming, is much more difficult. Matter of fact, I would claim it's not even a meaningful question. Because we're part of a complex system, and we only contribute 2% to the CO2 that circulates in this planet all the time, and to somehow pick that out and say that's responsible for all the changes in the nature of a complex system with the butterfly effect that I talked about really doesn't make sense to me. So my bottom line is that really most of the current view about global warming is based on very little knowledge and a lot of beliefs and values. Now, before anybody who's a climate scientist gets upset, I'm going to tell you a little story about Einstein. Because you can't be upset if you fall into the same problem that Einstein had. Well, as you all know, Einstein did many amazing things, and it was because he had a very powerful tool set of mathematical equations. And he developed relativity and all that. But Einstein had a very strong belief as a human being. He believed that the universe was uniform and continuous. He did not believe it started and ended. And so he looked through his equations over and over again and see if he could find the answer to explain the uniform universe, and he couldn't. His graduate student came along without that belief and found in Einstein's equations the theory of the Big Bang. So we, as scientists, when we have our speculation, we do it within some reference frame, and it really restricts our ability to see and understand something else. So we all have to worry about that. We have to worry about groupthink in science, just like we have to worry about it in other areas of belief. So, and finally, if you ask the question, is global warming a threat? Well, that's a much more difficult question to ask. Because defining something as a threat is a matter of values, right? A threat to who, right? Is it the polar bears? Should we be worried about the polar bears? Is that how we define the threat? Or is the threat defined in what's better or worse globally for the whole planet, right? And in any case, we have this problem of not knowing what really is a threat in a more complicated way. Because my favorite example of this that I give in my class is, let's assume that we take global warming seriously, right? And in the process of taking global warming seriously, the world, for one of these other reasons, cools down. Well, then, the credibility of science will be given a severe shock, and so the next time scientists come up and say, hey, there's a danger here, they won't be listened to. And so something that happens that you're doing in the best of interest in the short term can actually result in the long term in a very bad outcome. So the question I'm asking is, why do we have this strong focus on global warming when we know these other threats are much more destructive and much more definite that they're going to have a destructive impact? The classic example is the asteroid impact. Right now we're spending 1% on that threat compared to global warming, yet we know how to solve it and we can develop the defenses to do it. So the question is, why are we making decisions like this? Why do we make decisions like we make about the New Orleans hurricanes? So to answer that question, we have to go look in our brain, because my assertion is that that's the source of both the opportunities we have to make better decisions and the problems we have in making them wisely. So I've already told you that our brain emerges was developed by merging three different components that have the first component started 500 million years ago, and the most recent one started with mammals 200 million years ago. In any case, we know now that the most significant part of our human brain that distinguishes ourselves is our frontal lobes. And that in our brain, we allocate much more space, in our case 29% of the cortex is to the frontal lobes, than it is in any other mammal. And we also know from studies that the frontal lobes are the source of our concept of planning and time. So that very distinctive ability is the exact ability we need to deal with the challenges that lie ahead. However, just reminding you again, this brain was designed when we were in an I-we threat framework that was survival of the fittest, where we had to deal with imminent and local threats, right? And yet the question is now, how do we deal with these problems that are not so imminent and that are global threats? So, as I said to you, or maybe you know, that brain imaging is offering an enormous insight into looking to how we think. Now, I claim besides the knowledge these brain imagings are giving us, it's going to have a profound impact on us, because we're eventually going to use these tools as a feedback mechanism to improve our decision-making ability. But that's a story of another day. So what have we learned from watching us think? Well, the first thing we've learned, which we always knew, was that when we get fearful or get upset, we don't think. We now understand that the amygdala sends out a pulse that actually shuts down the cortex so we can't think. Because to survive, when you met a tiger in the woods, you didn't want to do a complex analysis. You wanted to get out of the way as quickly as you could. So that's the way our brain is wired to function. You have a fear, you get one of these primitive emotions, it actually shuts down the cortex and doesn't let it think. And that's the basis, of course, of the fight or flight reaction. But emotions are also very important to us. They're at the essence of our sense of ourselves. And that turns out to be also true and revealed by neuroscience. Because emotions determine our memory, how much, if we feel strongly about something, we remember it. Many of you can remember incidents in your lives that just stand out, and they usually have a very strong emotional component to them. And learning is turning out to be an emotional experience, and that has something to say about how we teach in our colleges, but that's a whole other subject, because we certainly don't make it an emotional experience. But the most important thing for me is the work of Joe Ladeau at NYU. He has divided our emotions into two classes. And those are implicit emotions. Those are the emotions that the neocortex does not get involved in. And what he calls the explicit emotion, which is a dialogue back and forth between our amygdala or so-called reptilian brain and our cortex. And very importantly, and very recently, it was discovered, and actually for me, I discovered it because a student in my class, after I gave her the whole course, she said to me, well, okay, Professor Eisenberger, I believe in designing Earthlings, but are we going to be happy It sounded pretty antiseptic. So it took me a long time, but I finally discovered that we found that neuroscience has said, yes, we will be happy. There's some work done at Iowa that shows that our neocortex has a positive feedback loop when we successfully apply knowledge that secretes the same chemicals in our brain to make us feel happy that is secreted when we use our primitive emotion to meet our basic needs. So the neocortex needed that feedback loop, and it is in the successful process of learning, applying our knowledge. That's very important because that means we have as a feedback mechanism something that's going to encourage us to do it. We're not fighting an uphill battle against our primitive instincts. Now, the second type of constraint that brain imaging has directly revealed, and again won't be surprised to many of you, is the fact that mathematics is not really natural to most of us. It's people like myself who are the freaks. Most of the people in the world who can't understand mathematics, that's the normal state of affairs. But more importantly, what we've shown, and it was shown by Kahneman, if you give people a logical puzzle and make it more and more complicated, at some point they stop thinking and they switch and they just guess. And they use their intuition to guess. However, the problem with our inferences that our brain makes, those inferences were crafted when we were in this evolutionary period of survival of the fittest, and yet they have to be applied in this era now where we are driven by a knowledge-driven world. So a good example of how that works in many cases that we don't have time to think has been popularized in the book called Blink, where you show that you make many decisions without having the possibility of doing all the computation. You're really an automatic pilot. You're really reacting in a very predictable manner. And there's something called neural optimism that facilitates that. That neural optimism is you take very little information, and then that triggers a subroutine in your brain that runs the movie of what reality is like. Now, to show you that it's really what happens is this fascinating experiment, which a friend of mine took, where you see a movie, and after the movie's over, you're asked, did you see a gorilla in the movie? The movie is of a family having dinner. And everybody says, at least my friend said, well, I just saw some blurry figures. Well, then they replay the movie, and in fact, the gorilla's all over the place, beating up the family. But because the person took very little information and said, this is a family having dinner, their brain created the story for them. They weren't continually processing information and getting more information. Now, in addition to having these problems with making complicated decisions, we do have some assets. And the most important asset is, and this has been shown in a wonderful book, Natural Born Cyborgs by Andy Clark, our brain is really indifferent to whether the source of information comes from inside our body or outside our body. The simplest example of this is the use of a tennis racket. The brain doesn't know the difference between our hand and a tennis racket. After a while, it becomes an extension of our body, right? But even more important, another good example of that is the idea of the glasses that invert reality. There are glasses that invert reality, and you put them on, the world looks upside down, and you start touching the table and figure out where the reality is. The glass, your brain will flip the image and make it right side up. And after a time, it can train itself, so when you put on these inverting glasses, the world is automatically in the right direction. So the challenge is going to be for us, if we want to seek assistance and tools to be able to enhance our ability to deal with these complicated knowledges we have to do it in a way that we can, just like the tennis racket, that we seamlessly integrated into ourselves, so we can have this exchange with all the knowledge and all the capability that we have available. So the final thing that I want to bring into that affects our brain is the fact that we have two different forces driving us, and sex is the best example of it. We have the primitive, historical, reproductive, survival need that drives our sexual impulses. And then we have that's called the ultimate drive. That's what started it. Then we have the proximate version of it, which is to have pleasure. And when we have pleasure, we think about taking contraception and make various decisions that integrate our feelings about sex with knowledge. So there are general conclusions that we can come from this, and let's see what impact they have. They're listed on the bottom there. And the most important one is that we really come predisposed with a set of inferences about the world is connected, that's built into our brain, even before we have any knowledge or anything else, because of our evolutionary history. So we now can define what it means to have our brain imposing a constraint on our ability to make decisions. The first is that we want to make decisions based on the proximate causes, not the ultimate causes. We don't want to have our implicit emotions dominate. We want our explicit emotions to dominate. And we want to be able to evaluate the knowledge, and we want to be able to understand the limits of what we can predict. So the fact is, and I'm not going to go into it, if you look in detail at global warming, all those constraints are at work. So it's not surprising we're having a very popular reaction to the threat of global warming. But even more profound, I think, is if you look at what happens with a brain that functions in a survival of the fittest framework with these constraints, and you see you look at the pattern that I described here, and then read the steps each one and ask yourself, that's not the recipe for the Iraq War? Is that not how we get into wars in general? Right? And so it's clear that if we stay in the other framework, that it's very likely that we'll use our knowledge destructively in our battles with each other. However, I'm suggesting that just like in this talk today, if we can comprehend that we have this limitation, right, and that we are each here in this room trapped in our reference frames, that can begin to develop a new compassion for our dialogues among each other, recognizing the separation that exists between us, and that compassion can be the basis for changing our reference frames, and that then we'll find a way to play a more constructive role in the co-evolutionary challenge. So, what's the bottom line conclusion from all our study of our brain? Well, it says that applying our knowledge together successfully against a common external threat will make us happy. This is very important because what it says really, when we do this, we're combining our two most strong instincts, our desire to survive together with our desire to use knowledge successfully. So we really have a good chance to do this because we're going to feel happy. The brain's going to secrete those chemicals and we're going to feel good about doing that. Now, there are ways we can start to address these things, and I don't have, again, in the time available, go through all the details. But first, we can develop the emotional constraint by what I would call sort of some form of global psychiatry, some version of global anger management. Basically, we have to, as a species, get our implicit emotions under control and depend more and more about our explicit emotions, finding a way to integrate our knowledge and our values. Secondly, the complicated constraint, as I said, is what's going on in the computer sciences departments around this country right now. They're all working on ways to how, implants, other ways, how to seamlessly connect our brain to all the knowledge that's out there, right? In a way that's seamless, that the brain won't know whether the data is stored in some computer that you can get from a Google that's done without having to type on the thing, or it's stored inside, because the brain really doesn't care. As long as that interface is done seamlessly, the brain won't know the difference between whether the thing is stored in a computer or stored in its head. Now, we also have to, clearly, once we get the knowledge in effectively, we have to improve our learning skills. And clearly the issue is not to understand content. Content in 70 days changing, we can't hope to imagine that. We're going to have that stored someplace. But we have to learn how to use it effectively. And I'm involved in a project at the University of Arizona which is beginning to try to address this challenge, and it's called Pathways to Learning. And the basic idea is, how do you personalize all this knowledge out there so it can interface with your brain, all your different brains, all your different interests, in a way that you don't get what Google gives you, you get a selected portion that's well matched to what you need to make the decision you want to make. And finally, it tells me the idea that we are trapped all in this different reference frame and that science is vulnerable to groupthink. Groupthink is we need a new institution. I call it the knowledge court. And the idea of the knowledge court is to act as an independent body to say whether people who are asserting something have at least gone through a rigorous process. They're not going to evaluate the details of the science, but do they have evidence? How have they evaluated evidence? How have they done their statistics? How have they done their analysis? Have they, in fact, followed a rigorous process? I claim this is very important because, as you know, for example, we knew about the danger of smoking for a long period of time, but we'd have people come up and, on very flimsy evidence, try to question it. We have to be able to be more efficient in deciding when somebody asserts something, whether it's just spin on Fox News, or it's in fact a reflection of some deep understanding that has evidence behind it. And of course, from my perspective, one of the first questions I would give to this knowledge court is, Why are we focusing on global warming versus other threats? Is that, based on the knowledge we have, is that the right decision to make? So now we are ready to go to the next component. We've talked about our brain, and the second thing is now our social institutions. How do we organize ourselves to make decisions? What do we know? What can we learn about that from looking at what we've done in the past? A good insight to that was, in my opinion, was developed by Jared Diamond in his two books called Guns, Germs, and Steel and Collapse. And basically what Jared Diamond suggested was, starting from the ultimate factors, which is the environment in which we evolved, working down to the modern day where we're totally determined by proximate factors, which are how we use knowledge, and that this transition occurred by first recognizing that we could domesticate plants and animals, and therefore we could end up in an agricultural society where few people could provide the food for many, and therefore other people could spend their time learning and innovating. And therefore, because of that, the societies that were able to get more and more people learning and innovating together became more and more successful, and so we had this evolution, clear social evolution, from hunter-gatherers to villages to cities to nations, increasingly complex social organizations, increasing levels of cooperation, because of the fact that that cooperation enables us to develop knowledge better and to use it more effectively. And clearly, we're poised for the next step, because in his book, Collapse, Jared Diamond suggests that all the main reasons we have failed is because we make poor decisions. So the two issues that confront us, the two challenges we're facing, how to globally cooperate and how to make improved decisions, are clearly something that are the next steps if you look at our social evolution. Just summarizing that here, we just look in more detail in the I-we threat framework again, that over time, our human social organizations became more and more complex, and our values have evolved gradually from the eat or be eaten reality of the survival of the fittest framework to increasing more cooperation and trust. And I listed here the general trends, but the very encouraging thing to me, the almost amazing thing to me, is we're on the right path. We're contemplating how to take on globalization. We are talking about more complex organizations. So we are really poised, and as I'm suggesting, we're trying to find ways to make better decisions. So we're really heading in the right direction. It's not like our species is heading in the wrong direction. This is, to me, a very positive result. And so the question is, in our initial attempts, what have we learned so far when we tried to do things together to solve problems? Well, first, the most examples that predated our global efforts have a great lesson for us. And that's when we tried to manage ecosystems that we thought we were hurting by our activities. And here we have been a dismal failure, again, like in New Orleans. We've been a failure because we failed to understand that it was a complex system. And the best example is the Yellowstone fire. What we did for years before, the Park Service had the practice of putting out small fires, preventing fires from occurring. Well, what happened eventually is that a lot of dry wood accumulated, and there was a catastrophic fire. So our attempt to try to manage it in the short term resulted in an unexpected catastrophe later on. And that suggests we have to be very careful, as I suggested, how we go about doing these things, because we're dealing with complex systems. Now, to me, by far the best example we have of how to address threats to us is the one that we've been spending the most time on. That is how human health. Human health, our concern for health is one of our basic notions from the beginning of our species, right? And it is the most evolved. And the World Health Organization is a good example at the macroscopic level of what we should be trying to create. It has two parts, and it's very important. These two prongs are very important. It's getting back to our El Nino example and our dams. One part is a solution, a specific solution for known diseases that we know exist and what cures we have. And therefore, then we're monitoring and looking, the World Health Organization, looking for an outbreak of those diseases by monitoring the planet and then providing well-established plans that they develop in advance how to deal with them when they emerge. But there's a second unit that's continually doing research and trying to discover new ways that we can approach these threats and looking for new threats that we have not yet identified. So they have this two-prong approach. It's also clearly a global organization, having laboratories around the world that are collaborating with it, over 250 laboratories, 140 countries are involved, and it's really a good model for what I think we need to do. So what I'm suggesting is, in an institutional sense, an important component is we have to set up what I call the Healthy Planet organizations. And that would mean setting up a WHO-like organization for each of the global threats that we face. Now just think what that does. Those threats affect us all equally. They're a common enemy. It's not who's going to be winning. We don't know how an asteroid is going to hit anybody, right? So it provides really the basis for us working together against a common threat, and therefore developing the trust that comes about from doing that. And also, I want to remind you that that's not only important in a complex system for the global threats, because imagine that if we don't develop this trust and we have a serious interruption in our energy. Well, how long would America sit still if there was no energy coming in? Wouldn't we start killing each other and fighting? Couldn't we make the reaction, the feedback from the deprivation in energy worse than the act itself? So we have to develop this global trust in order to survive positively. So now we're at the end of the talk, and I'm going to try to pull all this together and then apply it to global warming for you, specifically. As I said, it seems to me that it's fairly clear that the most important value we have determines how we interact with each other, and that will facilitate this increased cooperation we need to address the threats we face. And the clear to me that from a secular point of view is driven from understanding how the brain is to understand that involves something like the golden rule. Having compassion for other people's stories, having compassion for understanding the human condition, and using that to build a bridge between us. But even before we had all this knowledge, as you know, the golden rule is basically the most common adage and the most common value shared by cultures and religions throughout the world. So what's I find fascinating is that a very detailed analysis of a strategic imperative to develop ways we can trust each other and cooperate, right, which is necessary for the next stage in our social evolution, is exactly the thing that was argued long time ago when we had no knowledge and had no need for such desire, but it was applied in a more local manner. So that's a very important thing, and now if you take that together, now you can come up with the I-We threat network for Earthlings. In this case, we're practicing the global limit of the golden rule. We are all us. We are a species. It's not you and me, us and them, it's us. And very importantly, in this notion about trying to bridge this sort of existential isolation we all have, captive in our reference frames in our brain, I claim that we're going to go and build the bridges, and we're going to move from a more I-oriented, isolated perspective to a more we-oriented, understanding and being able to communicate better with each other. That will build trust. That will result in global cooperation. And if we use the golden rule in designing the solutions, I claim we'll start a very positive feedback loop that offers us a very bright future. So the recipe is fairly simple. Use the golden rule, make improved decisions, and implement them through new organizations in the way I've described. Now let's go and try and apply this in detail for a moment to the issue of global warming. Okay, I'm not going to go through all the specifics about the global warming threat again. I'm just going to make one important point that is usually overlooked. We cannot solve the global warming problem by conservation. We cannot solve the global warming problem by just making our coal plants not pure CO2. It's only 30% of the CO2 we put in the atmosphere. And as Tom Friedman wrote in his op-ed just yesterday, or maybe it's today, he pointed out that in this 5 to 10 times growth that we're going to have in our energy utilization that's driven by our removal of poverty, it's going to overwhelm anything we can possibly do by conservation. So we need, as he suggested, and I agree with, is that we need a completely different relationship between our use of energy and our planet. We have to fundamentally change the paradigm. And I'm claiming the solution to that is actually was thought about by a professor here, Klaus Lackner, and that is instead of trying to clean up the flue gas, we want to be able to take the CO2 out of the atmosphere itself. In that case, we can actually have what I call a global thermostat. If we take more out than we're emitting, we'll reduce the amount of CO2 in the atmosphere and we'll cool the planet down. If we let more CO2 build up, we can let the planet heat up. So in that way, we'll have control of the planet, and we don't care, just like in other examples, we can't tell what's the real cause, whether we're the cause of it or the sun is the cause of it. We have a defense, and we get rid of this debate about whether we're the villains and just say there's a real threat out there. It is a real threat, climate change. And here's a way we can cooperate globally to develop a real solution to it in terms of being able to absorb the amount of CO2 that's in the atmosphere and therefore determine the temperature. And the particular notion that I've come up with in conjunction with another professor here, Professor Chilchinsky, is a way to use renewable energy, the heat produced from renewable energy, to extract CO2 from the atmosphere. And in doing that, we have the following new era in our relationship to energy use. That is, the more energy we use, the cleaner we're going to make our planet. The more energy we use, the more CO2 we take out of the atmosphere, not the more CO2 we put in the atmosphere. And that's going to be a radically changing paradigm that will let us use energy as much as we want, meet our needs of growth, right? And therefore be able to take care of this 5 to 10 increase without damage, and also at the same time be sitting there ready to adapt as the various forces in the complex system tend to change our climate. Now, how do you go about implementing that using our golden rule values, right? So we want to use the golden rule in every step of this way to build the trust necessary to have a successful implementation. First thing we have to do is remove this we-they between the developed and the developing countries. That's a problem with the current Kyoto Protocol, and that has to be gotten rid of. So how do we go about doing that? This is also something that Professor Chilchinsky has had an idea about, but let me describe it in terms. She uses other words. Let me describe it here. So first of all, we want to practice the golden rule. The first item of the golden rule, everybody on this planet has the equal right to the amount of CO2 they put in the atmosphere. I don't have more right than somebody else. We have to really say that. Also, the golden rule will say, hey, the poor people, the people that are poor right now, if you were poor, you'd like to be helped, so we ought to help them. Right? How do we help them? Well, the way we can help them is we can give them our technology and give them the financing so they can develop renewable energy sources in their countries. And when they do that, we'll make our companies, our economies will grow in providing the technology. And so we can end up in a situation where they have more energy so they can develop and meet their needs. America and the developed countries are having outlets for their technology, and therefore they are also having increasing wealth. And so together we can create this win-win solution by sharing each strength we have and applying the values of the golden rule. So I've listed here again on the bottom how we would actually set the temperature of the global thermostat, which is an interesting exercise to think about, and I'm not going to take you through that here today. But again, it involves a two-pronged approach. One, we're sitting there ready to respond, like in the WHO organization, to any changes and adapt to them by changing the amount of CO2 in the atmosphere. At the same time, we're going to have a research organization that's looking for ways that we can get early and early warning of how to manage the planet better, to have global climate health. So let me now end by summarizing what I've tried to communicate here to you today, that in changing this we threat framework, I claim our knowledge suggests the following. We need to change from a survival of the fittest reality that we've come from, and that still lingers in our views of competition and the conflicts that are raging in our planet, to a golden rule approach. We have to make the transition from competition to global cooperation and build more trust. And most importantly, we have to bridge the gap between us. We have to use these new understandings about how our brain works to try to find a way to develop compassion for each of us who are trapped in our own reference frames and find a common reference frame in which we can all communicate. And we have to change the way we make decisions. We have to use and will use tools to make those decisions. Just like, I know that we have this very funny attitude about messing with our brain, right? But I claim it's no different than all these big cranes and all these big tools we have for physically changing the world. It's important that we take advantage of our knowledge and this fact that our brain is designed to interface with tools so that it can extend its capability outside its own head. And then finally, we have to change our relationship to nature. It's not leave it alone. It's not that we're the villains, but we can be the stewards if we make these changes. And we have to use our knowledge to manage the planet rather than to try to minimize our impact on it. But as I've tried to indicate throughout this talk, that at the same time that I've been doing this secular sort of standard work of an academic, this has had what has also had a profound impact on me is the personal aspect of this thing. Is that what is the impact going to be on all of us if we can get into this state? The fact that that practicing the golden rule requires compassion and cooperation, and it will create in us, and I claim in our brains, the secretion of these chemicals that are going to make us feel good. And so therefore I suggest that we should all find ways to become Earthlings and find ways to cooperate and address the threats we make. Thank you very much. Sure, please.
Thank you, Peter. Peter agrees to take questions. I have a question I suspect some of you may. So there are people behind us with microphones. Raise your hand and a microphone will appear before you. Then ask a question.
Early in your talk, you indicated that it would be difficult to figure out whether CO2 was causing global warming because it's less than 2%. Our contribution is less than 2%. The second point you made early on was that it may be a relatively small catastrophic kind of event when compared to, say, asteroids that we're not really spending any money on. However, at the end of the talk, you focus on global warming and removing CO2 as being a kind of an important thing we should do. So I was wondering how you reconcile that.
And I'm sorry for not being clear. I made a subtle switch between global warming. I made a distinction between global warming and climate change. So what I'm saying, historically, climate change is a real threat. You know, we have to worry about a snowball Earth. We have to worry about dramatic changes in the climate of the planet. I'm not sure global warming is a problem, but I know climate change is. And the idea of the global thermostat is it doesn't care whether we're the cause or there's some external cause. It doesn't care whether the planet's going to get cooler or warmer. It just gives us a defense against climate change, which is historically a well-known threat. Right? So that's the distinction between global warming and climate change.
You suggested a very interesting tactic, which is to extract CO2 from the atmosphere and combat tendencies to global warming. Of course, we already have such a tool. It's called photosynthesis. So maybe instead of just cutting down the rainforest and killing the algae cover in the sea, if we could design methods for a very efficient mechanism for removing carbon dioxide and replacing it with oxygen, we'd be partway along the solution.
Well, part of the problem with part of the problem with that is that the CO2 we put into photosynthesis goes back into the atmosphere eventually itself when the system decays. And so what we need, if we have in the carbon cycle too much in the atmosphere, right, because there's a continual recycling when you get in equilibrium with plant life, it's not going to really solve the problem. Right? So we really need to remove it, store it, and get rid of it. Right? Take it out of the carbon cycle. If for other reasons the amount of CO2 is going up or down. And also the ability to adapt quickly is not present if you have to plant a lot of trees all of a sudden because you feel that some threat is coming, whereas in fact we can turn these machines on that I'm imagining we can build, so very quickly we can change the amount of CO2 in the atmosphere.
Thank you. I have a couple of questions. I was rather interested that you, when you described the developments of mankind through the last couple of centuries, you didn't say that specifically. There was nothing whatsoever said about the effects of medicine and its relation to the population increase, which to my mind is, in my lifetime, population has tripled.
Right.
I think that's something very unusual. It has never happened to mankind before. That's one question, why you ignored that. The second question is, I'm at Columbia University, where education is regarded to be very important. What you have told us is how we should be thinking about it, but how are you going to educate the population or even our leaders to even think about what you are talking about?
Well, okay.
And that is the second question. And the third question is about the technical one, about your, carbon CO2 sequestration is fine. But I don't know, just like we have not been able to find out where to put nuclear power plant wastes, we also really don't know where to put safely CO2 unless you shoot it to the moon, but that, as far as I know, is not economical.
Okay. All right, now, I'm getting old, so we can, one question at a time.
Right.
So tell me, what was your first question? Just give me the key word again.
The first question was about population.
Right. Well, the evidence is quite clear on two fronts. Humans, in general, when they get out of poverty, they stop having children, and they reduce the number of children. So what used to be viewed as a global threat, the increased population, is no longer viewed. Matter of fact, it's now the current model is that we're going to peak at some number of population and then decline, as is happening in Europe and would be happening in this country. And what it is basically is human beings, if they don't have to use their children for labor, they value their free time and they don't want to have too many children. And that seems to be a very common thread. So that's number one. So, and the second thing is, I actually view having millions of people in China and India also doing and learning knowledge in a future society. So we have more and more people who are learning and innovating as a positive thing, because we got a lot of things we have to deal with, right? The second question.
The second question was, sorry, my brain is...
Oh, yeah. Oh, yeah. Well, as I said, my thing about education is we're working on this project in Arizona that is really in direct opposition to what I call the current mass production approach to knowledge, like me up here speaking with one set of content to this diversity of brains and thinking that I have a statistical good chance of connecting to it, right? So what really we now realize is that we have to personalize the delivery of this knowledge so that it interfaces with everybody's brains here in ways they can comprehend. And that's what we're trying to do. Initially, we're doing it in an awkward way because you're going to be on a PC. But whenever they develop these devices that we can carry around and remotely connect to, the same idea of how you extract from all the knowledge we have exactly what the person needs to make the decision they want, and maybe even some tools to make the analysis, right? That's where we're heading, okay? And how to convince them, all I can tell you is there is a group made up of many of the major corporations that suggests that we need new learning skills, what they call 21st century learning skills. And you know what they say? Working together. Not the hero scientist, right? They say, don't learn about content. They say, learn how to use and learn. So all the things are there, really. They've identified, and if you want to Google and see 21st century learning skills, you'll see there's a movement developing that's suggesting our educational system needs to change, and it's going to be a long time before that happens. Third question.
The third one was about how could you practically do the CO2 sequestration?
Right. There's two answers to that. In the short term, there's plenty of underground geological formations to store it. In the long term, I didn't have time to go into it, but this process can be done cheap enough. So what you're really going to do in the end is we're going to generate what I call a renewable hydrocarbon fuel to run our cars. What the idea is, we take the CO2 out of the atmosphere. Instead of burying it, we then use the energy, let's say, that we're developing from the sun, solar energy, to get hydrogen, and then we use a Fischer-Tropsch process and we make a fuel. And calculations show that we can use the technology once it's developed and make fuel for $1 a gallon of gasoline.
The human variant of photosynthesis.
Excuse me, what?
Human variant of photosynthesis.
Exactly. And so therefore we can have a closed cycle of giving this renewable hydrocarbon fuel to our cars. They'll put it in the air, we capture it up, we create fuel again and feed it back again with no net increase.
This comprehensive question and answer leaves us with two more questions from this side of the room.
Right. Please.
With the idea of the knowledge body governance, how would it avoid the dilemma of the political options that mankind has currently?
What do you mean by the political option?
Well, I mean, how would it differ from the political systems that govern the planet now?
Well, I mean, what I'm saying, we're now still largely in the nation-state framework, right? And I'm suggesting, just as we used to be in a city-state framework, and before that in the village, and before hunter-gatherers, our next step is we're going to have a global framework of political. You know, maybe it's not the United Nations, but the United Nations is the beginning of the idea, right? But we have to go to that because the real challenges and the real benefit comes when we act globally. And so there's going to be a new politics, right? And that's why people, when you read, and there are courses at Columbia that never used to be taught before on globalization, because everybody recognizes that in some evolutionary sense, we're moving to different political structures, different views of how we should organize ourselves to deal with the problems we're facing. And as I said, what's so encouraging is we're on the right path, right? Our social evolution is in the direction that needs to be for the real threats that we face out there that can really hurt us. Nothing else can really hurt us than those threats. One other question? I mean, I could stay here forever, so, but I'm not going to, Bob says.
Thank you. What if people don't appreciate their compassionate dialogue after realizing the limitations of their knowledge? What if making that realization actually does the opposite?
Say that again, please.
What if realizing the limitations of their knowledge actually has the opposite effect and makes their dialogue actually depreciate in worth?
Right. Well, look, I mean, that's an important issue and it's sort of part of the discussion. The way I would answer this is the way, in some sense, evolution has occurred in the past. Some of us are going to adopt these Earthling principles. And if we show, by doing them, that we can outperform, are happier than, have a better existence than people who don't adopt them, then over time, they'll convert. So it may not be, in a sense, here's the truth, and everybody's going to drop down and change their view. But you can see the inclinations already there, and so some people, and I'm certainly going to put my efforts in to try to help more and more people do that, are going to do that, and then by doing it, they're going to show, I suspect, as Jared Diamond has described in our past history, that they'll outperform those groups that decide to keep the old model. Is that responsive to your question?
Yes. Thank you.
Right.
Well, okay, I'm going to ask you a question.
Sure.
It's difficult for me to phrase this question. It goes to the golden rule, which has, of course, the positive and negative variant, either do to someone what you would wish done to you, or the negative, don't do to someone that which you wouldn't wish done to you. In terms of a strategy for survival, it's got a very bad track record because it leads to the possibility of having something done to you which you don't wish to do to someone else, and that terminates your chance to do good. One thinks of the various ways in which people saying this have become martyrs in one or another religious context. So your prescription for how to go from here to there seems extraordinarily courageous of you to propose, and my question goes to, how do you avoid coercion, having convinced yourself of this? How do you actually, to use your word, convert, if not recruit, people to be as brave as you are, as to say, for the sake of that golden rule, you would, for instance, give up the capacity to force someone to do something? How do you make this work without being coercive in turn, and how do you protect this from coercion that would stop it?
Well, I guess there's several answers to that. Part of the answer is the one I just gave before, to the previous question. But another answer, I guess, is that it's very important in this process, as I see it, that we've identified this common enemy. And if we take this common enemy seriously, then it's going to take our attention away from doing to each other to hurt each other or get gain. And then we're either going to find out, hey, maybe we ought to work together and defend against these asteroids, and therefore we'll turn our energies in a constructive direction. So what I was trying to, and it didn't come out so clear, it's really the powerful combination of our primitive instincts for survival together with a new modality for survival that actually people understood a long time ago. But now it becomes critical, where it wasn't critical before. You could take care of yourself and not worry about the other guy, right? But now, with these global threats, that's not possible anymore. It's not logically possible. And once we become convinced of the seriousness of those threats, and that they really are on a completely different plane than all the things we're debating and arguing about, then it has the possibility of orienting us, and once you have the experience of working together, you can build that trust and transform the social fabric.
Okay. It's a responsive answer, thank you. I'm going to call this, just because we have booked this room and this event for a certain amount of time, but I'm sure you'll agree with me that Peter Eisenberger is a brave and clear man, and one hopes only that at least one presidential candidate will care what he says. So meanwhile, let's thank him.
Welcome you.